This is a wear testing device on which we can test the friction-reducing effect of Metabond products. The equipment is very simple. It consists of an electric motor that drives a horizontal shaft with a V-belt drive at the back. We attached a bearing outer housing to the visible end of the shaft, which is braked with a bearing roller fixed in the vise. First, we carried out a dry test with no lubrication, then with oil lubrication, and finally, a little Metabond is added to the oil. Differences resulting from friction will be visible on the amp meter, which shows the current consumption of the motor, and in all three cases, the amount of tension and load can be seen on the spring force meter. The most important thing is wear. In all three cases, new rollers are used, on which the wear marks can be seen. First, we perform a dry test, because there is no lubricant between the two layers which are rubbing against each other. Let's look at the maximum current consumption of the motor and the amount of tension on the spring force meter. At a load of 3 to 4 units, the friction breaks the electric motor and results in a large wear mark on the roller. I replace the fixed roller and now I pour a little engine oil into this oil pan. I put it under the moving outer bearing and start the engine again. We can observe the amount of friction in case of proper lubrication. At a tension of 4 to 5 units, the oil film breaks. A little smoke is produced because the two metal surfaces fuse or stick. As a result of the load, the oil film broke and the two metals ground into each other. If we now look at the wear surface, we can see that there was a little less wear than in the dry test. For the third test, we replace the fixed roller again, which we mount back to its place, and before we install the engine oil pan, we pour a little Metabond into the engine oil we just used. We place the fixed roller and fit the pan containing engine oil and Metabond, which provides lubrication, under the rotating bearing housing. After switching on, the first important change is that the squeaking sound will be reduced. It can be seen that proper lubrication has been established and that the equipment does not become louder as a result of the increasing load, but becomes quieter. The current consumption is far from maximum. This means energy savings and increased performance resulting from reduced friction. We have already doubled the load compared to the test with only engine oil without Metabond, and the oil film did not break. Metabond provides ideal conditions for the oil film due to its metal surface treating effect. It does not break the engine even at 3 times, 4 times, 5 times the load. On the worn surface of the roller used during the third test, we can see only a small shiny spot, the result of the surface treatment. The oil film did not break even with multiple overloads. Therefore, Metabond provides perfect lubrication. The equipment will not wear out with its use and runs more quietly. Metabond also minimizes cold start wear. With this test equipment, we can demonstrate Metabond's performance-enhancing, friction-reducing, and multiple life-enhancing effect, thanks to which the maintenance requirements of the equipment is greatly reduced.